So today we're going to talk about fractions, and then in the next section we'll actually graph fractions. And the algebra is pretty light in these sections, and there's not that much algebra per se, but the section's long. So I'll just jump right in and see where I go. So there's a lot of problems that we've already done, the kinds of things that we need to do, and it's just going to be revisiting or putting some different problems kind of together. That's going to make this a little different, but it shouldn't be too bad. So for problem 2, it asks me to do two things: find the domain, express your answer in words. To find the domain of any fraction, I take the denominator and set it equal to 0 and solve that for x. So in this case, the denominator is 2x plus 6. I'll show more algebra than I might for a lot of these problems, just because it's the first problem. So the algebra involved in setting the denominator equal to 0 doesn't give me exactly the answer to what the domain is. It gives me the number to exclude from the domain. I said express your answer using words, so I'm going to write my answer as domain is all real numbers except -3. And as long as the fraction that's given can't factor and cancel, like if this fraction, if I could factor and cancel the x out of the denominator, if I can't factor and cancel the x out of the denominator, then the number that we're excluding from the domain is going to show up on the graph as something called a vertical asymptote. A vertical asymptote will be a vertical line where the graph exists to the left and right of that line, but the graph doesn't exist on that line exactly. And the nice thing is, the equation of the vertical asymptote you get from the algebra for finding the domain. So question 2, the domain is all real numbers except -3, and x equals -3 is the equation of the vertical asymptote. I will show you how that appears on a graph here in a second. So we're not graphing yet, but just to show you how this is going to show up on a calculator. I brought this calculator today for whatever reason. If I hit y equals, shut my stat plot off because that will certainly mess me up. And I type parentheses 3x minus 12 divided by 2x plus 6. Might be semi-hard to see when I hit my graph button. We'll have not a window that's suitable. Let me go to Zoom Standard to get a window that's okay. And what's going to happen is that there's -3 on the x-axis. Let me tweak my window a little bit so it goes higher and lower, and I'll talk more in a second. Let me make my y-axis, my y's really get extreme from the 50s. This is 3 on the x-axis. The graph is going to exist to the left of 3 and to the right of 3, but not anywhere, not at 3. And the graph actually does exist even further as it goes off to the right, but the graph gets kind of close to the x-axis in this window. If I go back to a standard window, you'll see that off to the right the graph keeps going, but it's close enough to the x-axis where when I put that window at the 50s, you can't tell the difference between the graph going off to the right and the x-axis. But the graph does exist everywhere to the left and to the right of 3 on the x-axis. I can't draw x equals 3 without, I can't draw x equals 3, or x equal -3, should I say. So the graph exists everywhere to the left and the right of -3. I can't draw -3, x equals -3, which is the equation of the vertical line. That's the vertical asymptote, because it's not a function and my calculator can only draw functions. I can cheat. I can put something that's going to look like a vertical line. If I type in like 1,000 times x plus 3, this is going to draw a line with a slope of 1,000 that goes through -3 on the x-axis, and for all practical purposes, that's a vertical line. So when I hit graph, my calculator does that line's not actually perfectly vertical, but you can't really tell that it's not vertical. It's so close to vertical that it looks vertical. But the graph isn't actually ever, the graph of my fraction isn't actually supposed to touch this line ever. There's always supposed to be at least a microscopic gap between the line itself that I drew, the vertical line at x equal -3, and the graph. So this is considered a vertical asymptote, and it's the only place where the graph doesn't exist because -3 is not part of the domain. Okay, question 4 gives me another fraction, wants me to find the domain and express my answer using words. For any fraction, I find the domain by ignoring the numerator, setting the denominator equal to 0. Because this denominator has a square, I need to solve by factoring. Once I have it factored, I split the factors up, set the factors equal to 0. For the x plus 6, setting it equal to 0, I'll minus 6 from both sides and get -6. For the x minus 1, I'll add 1 to both sides and get x equal to 1. Those are the answers for my vertical asymptotes, but not the answer for my domain. My domain I'm going to write in words because it says to write it in words. The domain is all real numbers except -6 and +1. That's all I have to do for number 4, part A. For part B, the equation of the vertical asymptote is going to be x equal to -6 and x equal to 1. There's going to be 2 of them, which means, well, I sketch a graph of this just to show you what it looks like when I go y equals clear, clear. I do y equals 3x minus 18 divided by, when you're graphing fractions, both the numerator and the denominator have to be in a parentheses, divided by x squared plus 5x minus 6. Let's go to a zoom standard real quickly. When I do zoom standard, I might be able to see how the domain works. I might have to make the y's go higher, but to the left, the graph doesn't exist at a vertical line that goes through -6. It also doesn't exist through a vertical line that goes through 1, but it exists everywhere else. Again, here the graph is getting so close to the x-axis that you can't tell the difference, but that the graph goes on to the right, but it does. Let me draw the vertical asymptotes in. I'm going to draw 1,000 times x plus 6 to get the vertical asymptote drawn at -6, and do 1,000 times x minus 1 to get something that mimics a vertical asymptote but x equals 1. So you can tell that the graph exists, and you can see the graph to the left of, on either side of -6 it exists but doesn't exist at -6. Similarly, on either side of 1 the graph exists but doesn't exist at 1. And again, here the graph gets so close to that vertical line that my calculator isn't refined enough to show the gap, but there is a gap always between the graph and the vertical asymptote. A graph will never touch a vertical asymptote or cross one. 6 is just the same sort of problem. We'll find the domain. For any fraction, I find the domain by ignoring the numerator and setting the denominator equal to 0. Actually factor that, that would be nice. Because the denominator has a square, I'm going to solve by factoring. It's not hard to factor that. I get x plus 4 equals to 0 and x minus 5 equal to 0 after I factor and set the factors equal to 0. And then the numbers to exclude from the domain are 4 and -4. So I'm going to say the domain is all real numbers. I'm going to be lazy and use something like this. Numbers except And I could just write plus or minus 4 because I'm excluding both 4 and negative 4. So that would be a perfect answer for 6a. And for 6b, the graph isn't going to exist at x equal, I'm going to have vertical asymptotes at x equal negative 4 and x equal to 4. And again, I'll just graph that real quickly so you can see this. So I'm graphing the original function, which is 3x squared plus 20x plus 12 divided by x squared minus 16. And one vertical asymptote I'm going to do at 1,000 times x plus 4. That's the one at negative 4. And I'm going to draw 1,000 times x minus 4. And when I sketch my graph, I'll get the graph of the fraction first. And then each of the vertical asymptotes is going to be drawn. And it's not so clear that this half of the graph is getting close to the vertical asymptote because you have to get pretty high to do that. If I bump my window up and change my y max maybe like to a 50 and hit graph, you start to lose perspective a little bit, but you might be able to see the impact of the vertical asymptote on this side of the graph a little bit better. But again, the graph is always going to exist to the left and the right of the vertical asymptote, but it's never going to touch or cross a vertical asymptote. So that's just back to a standard window for what that's worth. And in the standard window, it's hard to see that segment of the graph, but the only place the graph doesn't exist in terms of left to right is to the left and right, just at that vertical asymptote, but it exists everywhere else. For 8, I'm going to take the denominator and set it equal to 0 to find the domain. Because the denominator has exponents, I'm going to factor. First, I'm going to pull out a common factor of an x. After I factor out that x, I get x squared plus 5x minus 6 equal to 0. I'll factor more. I'll go x times x plus 6 times x minus 1 equals to 0. It's going to give me 3 vertical asymptotes, one at 0, one at negative 6 when you set the x plus 6 equal to 0, and one at positive 1. And I'm going to write the domain as all real numbers. Except 0, negative 6, and 1. 0 is actually the x equals 0 is actually the y-axis. If I draw this on my calculator, this vertical asymptote, that is the equation of the y-axis, and I don't need to even type it in. So if I did this equation, 3x minus 18 divided by x up arrow cubed plus 5x squared minus 6x. I have 3 vertical asymptotes. One, I'm going to do 1,000 times x plus 6 to get the one at negative 6. And I'm going to do 1,000 times x minus 1. And then the third one being, because it's at 0, it's an axis, I don't need to draw it. And so the graph is going to exist everywhere to the left and the right of negative 6, everywhere to the left and the right of 0, and everywhere to the left and the right of 1. And now you can kind of see a bit of what's going on here. So there's the vertical asymptote at negative 6, the vertical asymptote at the axis of 0, and the vertical asymptote at 1. Our calculators only do so well in terms of drawing pictures. So again, there's the ones at negative 6, the axis at 0, and there's the one at 1. And that kind of segments the graph into 3 pieces for what it's worth. And the answer to part B, the equations of the vertical asymptote, there's 3 of them. One has an equation of x equals 0. Another has an equation of x equals negative 6. A third has an equation of x equals 1. And when I go to graph those, because I can't type x equals the 6, because the equation is solved for y, and a vertical line isn't a function, I cheat. I take 1,000 times the factor that made the vertical asymptote, and that gives something that looks like a vertical line from my calculator's perspective. Even though it's not perfectly vertical, it's actually slightly slanted, but you can't really see the slant. Okay, so for 10, same deal. I'm not even going to graph this. It's a nice, easy problem. Find the domain. You take the denominator, you set it equal to 0. There's no square here, so I don't have to factor. Just add 8 to both sides. 8's the number to exclude from the domain. Asked me to write the domain in words, so I did that. And the vertical asymptote is going to occur at x equal to 8. So if you draw a vertical line through 8 on the x-axis, the graph is going to exist to the left of that line and to the right of the line, but it won't touch nor cross that line. Same deal, finding the domain of a fraction. You ignore the top, set the bottom equal to 0. Can solve this by factoring because there's an exponent. That's a nice difference of squares. It factors into x plus 5 and x minus 5. Once you get it factored and set equal to 0, you split the factors up, set each one separately equal to 0. The factor of x plus 5 tells me negative 5 needs to be excluded from the domain. The factor of x minus 5 tells me that 5 needs to be excluded from the domain. And so for this one, I'd say the domain is all real numbers except 5 and negative 5. And I'm going to have vertical asymptotes at x equal to 5 and x equal to negative 5. And I could draw those vertical lines and the graph so you could see them, but I think I did enough of those on the non-interesting problems, which just would be considered a non-interesting problem. The next problem is interesting. Well, maybe not interesting to you, but somewhat interesting, because when I go to do my algebra to find the domain, I take the denominator, set it equal to 0. X squared plus 25 is prime because it's a sum of squares. So I'm going to solve it with square roots by subtracting 25 from both sides and getting x squared equals minus 25, and then going square root plus or minus square root. And this gives me x equals plus or minus 5i. So I wouldn't be necessarily wrong to say the domain is all real numbers except plus or minus 5i. But in terms of a graph, i's don't show up on our graph. Only real numbers show up on the graph. And I'm not going to exclude i's from my domain. And this is not going to have any except. The excepts in the domain answer are reserved for numbers without i's. So this is just going to be all real numbers. And there aren't going to be any except on this. And it's actually not going to have a vertical asymptote. The graph is going to exist everywhere. And let me try to draw this and see how it works or looks. So I'm going to clear everything out that's in here because I don't need to draw a vertical asymptote. To do this, I'd go 3x minus 12 divided by x squared plus 25. And zoom standard just so I get a nice window. And unlike the last problems, well, heck, I don't really see much of anything here. The window's not suitable. Let me zoom in. Let me make my y's get a lot tighter, maybe negative 2 to 2 on the y's. Let's see if we can see more of what's happening. Yeah, I think you see a lot more of what's happening. So the graph exists, and it doesn't have the break in it like the other graphs. There's no vertical line at 5 or negative 5. If you look at negative 5 and 5 on the x-axis, there isn't a break there where the graph kind of exists on either side of that vertical line. So you don't have to have vertical asymptotes. The domain of a fraction can be all real numbers if, when you're trying to find where the denominator is equal to 0, you don't get a real number. The next problem is the same trick. So to find the domain of any fraction, take the denominator, set it equal to 0. Just like the last problem, this is a sum of squares and doesn't factor. So I subtract 1 from both sides, and I go square root plus or minus my square root, and I get x equal plus or minus I. And similarly, like the last problem, I'm going to say the domain is all real numbers. I'm I'm not going to exclude i's because they're not going to show up on my graph, and ultimately I'm headed towards graphing. And the vertical asymptotes, there aren't any, so the if any part applies for the last two even problems in this section because the domain is all real numbers, and that keeps you from having a vertical asymptote. So that's the first style of problem, minimal algebra, but they're going to be important in the next section to be able to find the domain in vertical asymptote of fractions. So hopefully you're masters at that now. The next group of problems want me to find x and y-intercepts. X-intercept is where the graph crosses the x-axis. Y-intercept is where the graph crosses the y-axis. I think problem 18 and problem 2 are the same problem. I know the domain of that, but that has nothing to do with where the graph crosses the x-axis. To find an x-intercept of any fraction, you just take the numerator and set it equal to 0. Fortunately, my numerator doesn't have a square, so I'm going to add 12 and divide by 3. And this graph is going to cross the x-axis at 4. I'm going to say the x-intercept, or where the graph crosses the x-axis, is a point 4, 0. To find the y-intercept, you plug 0 in for x. Can't just ignore the denominator. If I do the math in the numerator gives me 0 minus 12, which is negative 12. The math in the denominator, bottom or denominator, gives me 0 plus 6, which is 6. I get negative 12 over 6. This gives me f of 0 equals negative 2. And the graph is going to cross the y-axis at 0, negative 2. So let me go ahead and graph this and just show you. So I'm graphing, I'm not going to draw the vertical asymptote. I don't need to show it right now to show you the x-intercept. Again, when I graph a fraction, I have to put both the numerator and the denominator in a parentheses. And the window is not the best window, but it is actually not so bad. The graph is supposed to cross the y-axis at negative 2, which is right there, and the x-axis at 4, which is right there. If I just go to a standard window, I might be able to see this better. So zoom standard, because I had a window set up for the other problem. Right there's the x-axis, the y-intercept at negative 2. Here is a 1, 2, 3, the x-intercept at 4. If you want to check real quick, to check the x-intercept of 4, I'll go second, trace, hit enter on value. I'm going to type the number 4 in for x. And when I type the number 4 in for x, I should see 0. So just in case you didn't see that, I did second, calc, value, type in 4 for x, and it tells me y is 0 and plots the x-intercept. To check the y-intercept, I go second, calc, value, type in 0 for x, and hit enter, and it shows me y is negative 2. So I've checked both of them super quickly on my calculator just by using the second and trace feature, and then plugging the x-coordinate of the x-intercept in, and plugging the 0, the x-coordinate of the y-intercept in. To find the x-intercept, I just take the numerator, ignore the denominator, set it equal to 0. No square, so I don't have to factor. I add 18 to both sides and then divide by 3 and get x equal to 6. So the x-intercept is going to be the 0.60. The y-intercept, I plug in 0 for x. I get f of 0 equals 3 times 0 minus 18 over 0 squared plus 5 times 0 minus 6. Usually we cheat. All the pieces with zeros go away. I'm going to write minus 18 over minus 6. Cancel out the pieces with the zeros, and minus 18 over minus 6 is positive 3. So I'm going to say the y-intercept is the 0.03. Again, I can check that super fast if I care to check it. Hit my y equals button, graph the fraction, 3x minus 18 divided by parentheses x squared plus 5x minus 6. The graph should cross the x-axis at 6 and the y-axis at 3. There's clearly the y-axis at 3. Not so clear at the x-axis at 6. So I'm going to check it on my calculator. I'll go second, calc, value, type in 6 for x, And when I type in 6 for x, I hope to see 0 for y, because then that not plots the x-intercept. Even though you can't really see it so well in this window, the graph has an x-intercept of 6, 0. If I typed in 6 and it tell me y equals something other than 0, then I would have had the wrong intercept for the x-intercept. Similarly, if I do second calc value, type in 0, it's going to show me the y-intercept of 0, 3. So for all the intercepts, if you do second calc value, plug in the x-coordinate of the x-intercept, it will plot the x-intercept. It should say y equal to 0. When you do the y-intercept, it should plot the y-intercept for you as well. Oh. 22, unfortunately, is hard factoring. Ultimately, to find the x-intercept, I need to factor that. I'm going to factor this off to the side. I'm going to do bottoms-up factoring. I'm going to multiply the 3 and the 12. I get x squared plus 20x plus 36 when I go to factor that. To factor this, I need two numbers that multiply to 36 and add to 20. And that's 18 and 2, because 18 times 2 is 36, and 18 plus 2 is 20. If I'm doing bottoms-up factoring, I started off multiplying by 3. I'm going to divide by 3. The fraction 2/3 doesn't reduce. I bottoms up on that and get a 3x plus 2 factor from that one. And the x plus 18 over 3 reduces to x plus 6. Now that I have the problem factored, I'm going to dump off the factors, set each one equal to 0. The 3x plus 2 factor, I minus 2 from both sides and get 3x equal to minus 2. I divide 3 by both sides and get x equal to minus 2/3. The x plus 6 factor, I get x equal to negative 6. So I'm going to say my x-intercept is the point negative 2/3, 0, and negative 6, 0. So there's two of them. The graph is going to cross the x-axis in two places. For the y-intercept, I do f of 0 equals 3 times 0 squared plus 20 times 0 plus 12 over 0 squared minus 16. All parts with the zeros go away, and I get 12 over negative 16. That reduces by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. And I'm going to put the negative to the numerator. So the y-intercept is going to be 0, negative 3/4. Easy enough to check. So I'll do y equals parentheses 3x squared plus 20x plus 12 divided by parentheses x squared minus 16. Graph it. Check each of the x-intercepts. There's the x-intercept at negative 6. The x-intercept at negative 2/3 is there. And if I do that second calc value, type in negative 6, it's going to show that x-intercept at the point negative 6, 0. If I do second calc value, type in negative 2 divided by 3, it's going to show the x-intercept at negative 2/3, 0, but it gave me a decimal version of negative 2/3. And if I do second calc value 0, it gives me the y-intercept at 0, negative 3/4, but instead of writing negative 3/4, it wrote negative 0.75 because I don't know how to make my calculator give me fractions for the intercepts, so it gives me the decimal approximations. For the x-intercept of this one, take the numerator, set it equal to 0. No square, so I don't have to factor. I add 18 to both sides and get 3x equal to 18. Divide both sides by 3 and get x equal to 6. So the graph is going to cross the x-axis at the point 6, 0. For the y-intercept, I go 3 times 0 minus 18 over 0 cubed plus 5 times 0 squared minus 6 times 0. All the 0 pieces go away. The numerator, I'm left with a minus 18. The denominator is a 0. This turns out to be undefined because any fraction with 0 in the denominator is undefined. If you get undefined when you're trying to find an intercept, then it won't have that intercept. So when I go to graph this, the graph will cross the x-axis at 6, 0, but never cross the y-axis. So again, if I put my y equals clear 3x minus 18 divided by x up arrow 3 plus 5x squared minus 6x, hit my graph button, I'll see the x-intercept at 6 ultimately, and it's hard to see in this window. If I scrunch the window down to make the y's a lot narrower, maybe if I make the y's go to the 3's, you might see the x-intercept better. Maybe you will, maybe you still won't see it. You maybe have to go to the 1's to make the x-intercept pop out. So on the y's, I'm going to go down, and from the 3's, I'm going to the 1's and seeing if I can show that x-intercept a little bit better. Still not even that great. Oh well. I can show you it this way though, going second, calc, value, typing in 6 for x. When I type in 6 for x, I'm going to get 0 for y. And that shows me that's 0.60 is on the graph. Just can't see it because it's so the graph just doesn't have that many pixels to be wonderful for seeing all the features of the graph. And I could also show you that the calculator knows it doesn't have a y-intercept. When I go second, calc, value, and I type in 0, it's going to give me some sort of error statement because it doesn't have a y-intercept. It actually gives me y equals, and it just leaves nothing next to it, which means it has no y-intercept. So I can't find a y-intercept, there isn't one. Surprised it didn't give me an error message. (26), when you go to find the x-intercept and set the numerator equal to 0, so tempting to say x equals 2 is the x-intercept. That's not the case. 2 equal to 0 has no solution. There's no x, so there's no solution. And in terms of the x-intercept, there's going to be none. The graph is not going to cross the x-axis. Let me do the y-intercept real quick by going f of 0, which is 2 over 0 minus 8, which is 2 over negative 8, which is negative 1/4. So the y-intercept. So just because you have an x-intercept, you don't have to have a y. Just because you have a y-intercept, you don't have to have an x. So I won't be able to check per se that it doesn't have an x-intercept, but if I graph this function, 2 divided by x minus 8 and hit graph, the graph will always be far away from the it'll never cross the x-axis. Let me bump my x's out so you can see further on this. I'm going to go my x's from negative 20 to 20. And the graph never crosses or touches the x-axis. So the graph there's always a gap between the graph and the x-axis. So we say it doesn't have an x-intercept. But it does have a y-intercept of negative 1/4. To find the y-intercept, I go second, calc, value, type in 0, and it's going to give me negative 0.25, which is a fraction, which is the decimal version of negative 1/4. Okay, still a couple more of these. These I won't graph. For the x-intercept of 28, take the numerator, set it equal to 0, divide both sides by 3, you get x equal to 0. So the origin there, the x-intercept is going to be the 0.00. And for the y-intercept, I go f of 0 equals 3 times 0 over 0 squared minus 25. I get 0 over minus 25 when I get rid of the 0 pieces. Any fraction with 0 in the numerator is equal to 0. So the y-intercept is also going to be 0, 0. The graph is going to only cross the axis at the origin. Just to save some time, I'm not going to graph that, but you can check it for yourself. 30, x-intercept, take the numerator, set it equal to 0. No square, so I don't have to factor. Add 12 to both sides, get 3x equal to 12. Divide both sides by 3, get x equal to 4. And I'm going to write the x-intercept is the 0.40. For the y-intercept, I'm going to go f of 0 equals 3 times 0 minus 12 over 0 squared plus 25. It's going to give me negative 12 over 25, which is a fraction that doesn't reduce. It's going to be at the point 0, negative 12 over 25. More. Wow. X-intercept, numerator equal to 0. I go 2x equal to 0. Divide both sides by 2. Any fraction with a 0 in the numerator is equal to 0. So my X-intercept is going to be the point 0, 0. Y-intercept, plug in 0 for x. Because the x isn't negative, I really didn't need a parentheses in the denominator. This gives me 0 over 1. Any fraction with 0 in the numerator is equal to 0. So the y-intercept is also 0, 0. Yet still more of these. I feel like it's kind of overkill in the x and y-intercept problems. But it is what it is. Well, finally we're done with the x and the y-intercept problems. Next thing, horizontal asymptote. A horizontal asymptote is a horizontal line that the graph can cross kind of close to the origin, but eventually the graph gets kind of drawn to this. So to find an equation of a horizontal asymptote are horizontal lines, so they have the equation y equals. And to find the equation, you divide the leading term in the numerator, which is the 3x, the term with the highest exponent, divided by the leading term in the denominator, term with the highest exponent is 2x. Reduce that fraction, the x's cancel, and I'm left with 3/2. I claim that this line, y equals 3/2 or y equal 1.5, that the graph will, as I get far out to the left and far out to the right, that horizontal line the graph will be attracted to. And let me draw that to you. And this window that I had set might be nice. So I'm going to go y equals, I'm going to enter the fraction, fraction 3x minus 12 divided by 2x plus 6. And when I hit graph, I think where's my window at? My window's not going to show that. I like the x's at the 20s to show this. Let me make the y's at the 3s. So I'm showing just a real narrow band of this graph. And now I'm going to draw the line y equals 3/2. And so you can see how the graph is going to be drawn to y equals 3 divided by 2. When I hit my graph button, you'll notice that the graph is getting close to this horizontal line. If I went out farther, if I made my window on my x's go maybe to the 50s as opposed to the 20s, you'll see the impact of this horizontal line more. So you start to see the graph, and there's the line y equals 1/2. I call that a horizontal asymptote because the further I go out, the closer the graph gets to that line. A graph can cross a horizontal asymptote, but generally if it's going to cross a horizontal asymptote, it's close to the origin. So this is a horizontal line that the graph gets closer to as you get further left and further right. The farther out you go, like if I went from negative 200 to positive 200, you'll start to see that the graph and the line are almost one and the same. You'll see how the graph gets so close to that line that you can't tell with the resolution of the screen the difference between the graph and the line. So the answer to problem 34, the horizontal line that this graph gets close to as you move left and right is y equal to 3/2. 36. Let me do 38 before 36. Yeah. Bad ordering there. So I'll do 38 first. So to do the equation of the horizontal asymptote, I'm going to go y equals, I'm going to take the term with the highest power of x in the numerator, the term with the highest power of x in the denominator, and form a fraction with just those. That's going to be 3x squared over x squared. When I do this, the x squareds cancel. Don't have a fraction anymore. I'm just left with y equal to 3. That's going to be the equation of the horizontal asymptote. So to find any horizontal asymptote, I form a fraction writing y equals, I take the term with the highest power of x in the numerator, divide it by the term with the highest power of x in the denominator, and if the x's cancel, I get a nice horizontal line that's easy to draw. So if I draw this fraction, y equals, clear parentheses, 3x squared minus 20x plus 12 divided by x squared minus 16, along with the line y equals to 3. We go back to a standard window. you'll see my horizontal line, and you'll see that the graph crossed the horizontal line, but it crossed the horizontal line close to the origin. That can happen, but usually once you get far away from the origin, that doesn't happen. So a graph can cross a horizontal asymptote, never does a vertical asymptote. Let me bump my window to just go way out, make my x's maybe go to the 50s again. And when you see the x's go to the 50s, you'll see more the effect of this horizontal asymptote. Still crosses close to the origin there, but as I get way out to the left and way out to the right, the graph kind of settles in and kind of either, just lays on top or lays under that horizontal line, and it doesn't deviate from that horizontal line. The further out I'd go, the closer the graph would get to that horizontal line. It would never cross nor touch that horizontal line. So what 36 and 38 had in common is when I went to find the horizontal asymptote, the x's canceled, and that's kind of the nicest situation. That's the easiest situation for finding a horizontal asymptote. 36 and 38, when I go to find the horizontal asymptote, I take the highest powered x term in the numerator, the highest powered x term in the denominator, and write y equals, so in this case it's going to be 3x over x squared. If I need to, I can expand that x squared. That's 3x over x times x. I can cancel only one of the x's, and I have an x left and it's in the denominator. When you do this calculation, when there's an x left in the denominator, the x-axis is going to be the equation, is the horizontal asymptote. And the x-axis has an equation, y equal to 0. So the answer to part 36, question 36, is the equation of the horizontal asymptote is y equal to 0. And I'll graph this to show you. I'm going to graph the function 3x minus 18 divided by x squared plus 5x minus 6. Go back to a standard window. I'm going to take this 3 out. I don't need to do y2 equal to 0, but I can. Doing y2 equal to 0 is just going to draw a line on the x-axis. I'm not going to see that anyways because it's already a line there. Go back to my standard window. In the standard window, it's kind of hard to see the effect of the horizontal asymptote, but I actually can. Let me crunch way down on the y's on this. If I go window, make my y's go maybe to the 3's again, you might start to see that already the graph here is so close to the x-axis I can't distinguish the graph between the x-axis. But over here the graph is pretty far away. To show the effect over here, I'm going to take my window and make my x's go way to the left. Let me go make negative 100 on the x min, just so you can see the effect of the horizontal asymptote. So there you can see it drawing the line there. And the graph gets really close to the x-axis but doesn't cross the x-axis. Well, it could cross the x-axis, but not that far from the origin. So here it's going to be always slightly under the x-axis. And if I make my window go further out to the right, the graph again is here it's going to be always under the x-axis, but it's so close to the x-axis that you can't distinguish the graph between the x-axis. But nevertheless, the graph is being drawn to this like a magnet in some sense. And that happens when the denominator has an x in it after you do taking the highest powered x term in the numerator divided by the highest powered x term in the denominator. For 40, I'm taking the highest powered x term in the numerator, highest powered x term in the denominator. I'm going y equals 3x over x cubed. If I need to, this is 3x over x times x times x. Only one of the x's are going to cancel. I'm going to be left with 3 over x squared. When you're finding a horizontal asymptote, if the algebra leaves you a 0 and an x in the denominator, then the equation y equals 0, or the x-axis is that horizontal asymptote. So if I graphed this, y equals, well, it's just about Hey, really? Whoa. Oh, these were so subtly different. When I looked at these problems, I'm like, it's the same darn problem. It's the same in terms of the X-intercept and the horizontal asymptote, but they're different. The denominators were different. The x cubed plus 5x squared minus 6x in problem 40. In problem 38, the x squared plus 5x minus 6. The graphs are going to be different. If I graphed each of these, the graphs will look very dissimilar, actually. But in terms of the horizontal asymptote, they're going to be the same. So I think I just did that. So here's the graph that I just did, so you can remember what that looked like. Let me go back to a standard window. So in a nice standard window, that's the graph of 36, the 3x minus 18 over x squared plus 5x minus 6. And now I'm going to change that denominator to have x cubed plus 5x squared minus 6x. And all of a sudden the graph's going to look different, but it's going to have the same horizontal asymptote. So I'm going to go 3x minus 18 divided by x up arrow cubed plus 5x squared minus 6x. When I hit my graph button, the graph is not going to look the same. It's clearly not the same graph. But on the other hand, the graph, as I get far off to the left and far off to the right, it gets close to the x-axis, which is y equal to 0. If I zoom in and make my y's go like maybe to the 3's, you start maybe to see the effect. You see that the graph is just slightly above that x-axis, and here it's slightly below the x-axis, but it goes on forever. It doesn't stop. My calculator sometimes makes graphs of fractions look like they stop, but they don't. The problem is when the graph is so close to the axis that it's kind of just drawing the graph on top of the axis, and you can't see that it actually goes on forever. But the y-axis is the x-axis is the horizontal line that this graph is drawn to, and that's the equation y equals 0. (42), I take the denominator, set it equal to 0. Whoops, I'm sorry. Wrong problem. I write y equals. There's no x term in the numerator, so I have to take 2 for the numerator of my fraction. And the highest powered x term in the denominator is x. That fraction doesn't reduce. I still have an x in the denominator. So the horizontal asymptote, which I usually write like this, HA, is going to have the equation y equal to 0, or the x-axis is going to be the horizontal asymptote. Again, so if I hit my graph of this, clear this out, and do 2 divided by parentheses x minus 8, go back to that standard window, and already, even in a standard window there, I can see the graph is drawn to the x-axis, which has the equation y equals to 0. To see the right side, maybe I need to make my x max a little bit bigger. Maybe if I make my x max 20, you can see the graph is always drawn as I get further left to the x-axis, which has the equation y equal to 0. Even if I went out to 1,000,000, the graph isn't going to deviate. It's just going to settle in, never really stray away from the x-axis. Once it gets attached to the x-axis, going up left and right, it doesn't bump up and leave it. It just stays there. Lots of x-axes for these. Here's another one. I'll go f of x equals, whoops, I'll go y equals 3x over x squared, which is going to be 3x over x times x. One x cancels. I'm left with an x in the denominator. So again, you get y equal to 0 for the horizontal asymptote. I'm not going to draw that one, just to save a second. Another. I have too many y equals 0s here. There's an overkill on the y equals 0. For this one, I'm going to go y equals 3x over x squared, which is going to be 3x over x times x. It felt remarkably like the last problem. Oh, it's similar to the last problem, but the numerator's slightly different, and the denominator's different. But for horizontal asymptote computations, they're the same darn problem. Cancel out an x, I get 3 over x. When there's an x left in the denominator, y equals 0 is the horizontal asymptote. Even though it doesn't have a vertical asymptote, this graph, y equals 3x minus 12 divided by x squared plus 25 is going to be drawn to the x-axis. And you'll see in this window you can't even distinguish the graph between the x-axis. If I zoomed in on my y's, maybe made my y's go to the 2's, I might see a better picture. So you can tell the graph over here is it crossed the horizontal asymptote, but can do that close to the origin. And as I get further right and further left, the graph gets so close to the x-axis or the equation y equals 0 that you can't distinguish the graph between the x-axis. But it can cross a horizontal asymptote. Graphs will never cross a vertical asymptote. 48, same answer. I go y equals 2x over x squared, which is 2x over x times x. Cancel out the x's. I'm left with an x in the denominator. The horizontal asymptote is going to have the equation y equal to 0. Last skill, slant asymptotes. Slant asymptotes are, as opposed to horizontal lines that the graph gets attached to, slanted lines that the graph gets attached to. These, they're harder to see in terms of you really have to play a lot with your window to see the effects of a slant asymptote. So I'm going to do a lot of playing here to get my windows okay. But computationally, it's going to be the same. I'm going to go y equals highest powered x term in the numerator is 8x squared. Highest powered x term in the denominator is 4x. So this is 8 times x over 4x. The 8 over 4 reduces to 2. One of the x's canceled. I'm left with an x in the numerator. If that x was left in the denominator, I'd say x-axis or y equal to 0. But because that x isn't left in the denominator and the x's don't cancel, I say I have a slant asymptote. The equation y equal 2x is what this graph is going to be drawn to. I'm going to probably have to really work hard to get a window so that you can see the effects of this, but I'll do that just so you can watch me struggle a little bit, because it'll be good so you might start learning what I think in terms of trying to get a window to display the effects of, I don't know if that's 4x minus 5, but I think it is. Ultimately, wouldn't matter if the denominator was 4x minus 5 or 4x plus 5. For my y2, I'm typing the equation 2x. When I hit zoom in standard, it'll draw both graphs, but you won't be able to see the effects of the, well, you'll see a little bit of the effect. So here you can kind of see the graph is drawn to that line a little bit. You don't see any graph up here. I need to go way higher on my graph to see the effect of the slant asymptote. So I'm going to make my y's get pretty extreme here. I'm going to make my y's maybe go on the 50s. You start to lose perspective of how the graph looks when you start distorting the windows, but this just kind of focuses in on this feature of the graph. So there's my graph, and there's the line y equal to 2x. And that's a slanted line that the graph is getting closer to. The graph is going to follow this line all the way up and to the right and all the way down and to the left. So the graph of fractions don't have to track to horizontal lines. They can track to slanted lines, or just lines that don't have a slope of 0, should I say. Here it's tracking to a line that has a slope of 2. So the difference between this group of problems, 49 through 58, and the last problems, in the last problems either the x is canceled, which was like the best situation, there weren't many of those, or the x that was left in the denominator. When an x is left in the denominator, you get a horizontal asymptote of the x-axis. But when the x is left in the numerator, like I get for a few of these problems, you get a slanted line. So here, I'm going to divide the highest x power term in the numerator, divide it by the highest x power term in the denominator. This is 8 times x over 2x. 8 divided by 2 is 4. One of the x's canceled, but the x that's left is in the numerator. That forces a slant asymptote on me. I'm going to leave this extreme window. I'm going to draw both the function, the graph of 8x squared minus 6x minus 3 and then over 2x plus 5 it looks like. And then I'm going to draw 4x for my slant asymptote. And with this extreme window, having the y's so extreme, I kind of lose perspective of how the graph looks in terms of the x and the y-intercepts, but I probably can see the effect of this asymptote real nicely. I might even have to go further down. So there's my graph, there's the line 4x. I can see how it impacts 4x there, but not down here. I need to make my y's go way lower, and maybe my x's go out farther to see the effect. So I'm going to make my x's jump out to -20 to get further left. I'm going to make my y's go down to -100 to go further down, just to focus on the impact or how the slant asymptote affects the graph. So there's the graph in this distorted window. There's the line y equal to 4x. And you can see how the graph is starting to track that line. If I went further and blew this out and went further left and further down, or further up and further right, eventually, when I get far enough out, you won't be able to distinguish the graph between that slanted line y equal to 4x. The graphs will be on top of each other. There'll be microscopic distance between the graph and that line. But it takes a good ways to get the effect of the slant asymptote. It's not seen immediately like the effect of the horizontal asymptote. So the difference between these problems and the last problems is where the x was. If the x is left in the denominator, then you get y equals 0, or the x-axis. If the x that's left is in the numerator, you get y equals something that's a slanted with an x in it. And if the x's cancel, that's the best scenario. For this problem, I'm going to cancel the x's. 3 over 12 reduces to 1/4. And the equation of the line is going to be y equals 1/4 x that this gets attached to. So this is the slant asymptote. So when I graph this, I'll go back to a standard window in a second, but when I graph this, 3x squared divided by parentheses 12x minus 5, and I graph parentheses 1 divided by 4x. If I do a standard window, I doubt that I see the impact of the 1/4 x that well. So it's graphing the line, and it's graphing the 1/4 x, and no, it's not so happy. Maybe it is showing things that I don't understand. I'm not sure what's going on here, so let me crunch my y's a little bit, and crunch my x's a little bit. I'm perplexed on this graph, what I'm seeing or not seeing. So, interesting. Yes, so you can see, let me do even narrower. Let me go even narrower on the y's, maybe make the y's go from -2 to 2. There's the graph a bit, and now there's the line y equals 1/4 x. So because of that being a fraction, all of a sudden I didn't have to go that far out to see the impact of the slant asymptote. So the graph has, let me just take the slant asymptote off of this real quickly. So the graph has 2 segments. There's a vertical asymptote at whatever, when you set the denominator equal to 0, I think 5/12. And the slant asymptote at 1/4, when I draw it, it's almost on top of the graph already. So you can see the impact of this fractional slant asymptote quite a bit more easy. 56, take the highest power x term in the numerator, 8x cubed, divided by the highest x power term in the denominator, 6x squared. This is going to be 8 times x times x times x over 6 times x times x. 8 over 6 reduces to 4/3. I have an x left over. The slant asymptote is going to have an equation, y equals 4/3 x. I suspect that that's going to be hard to see because of the cubes and the squares, and I have to blow the window up incredibly far to see the impact of that. And I'm going to skip that. In the next section, we're going to do graphs of fractions, and I'll work more on showing pictures, but you got to be getting tired of seeing me show every picture. Because they're not asking me to graph any of the questions in this section. I was just trying to show you how the graph will look. This is an easy one, 58. X cubed over x squared is 3x's over 2x's. Cancel, cancel. I'm left with no fraction. If the x was in the denominator, I'd say it's y equal to 0, or the x-axis. Here, the x is left in the numerator. The slant asymptote is going to be y equal to x. Let me just graph this. So I'm going to graph y equals, and then x cubed divided by x squared plus 3x minus 4. And then, ultimately, I'm going to graph y equal to x. I'll turn this off for a second. Do a zoom standard. Here's the graph of the fraction without the asymptote drawn in. And there's graph over here that I'm not seeing. I'm going to bump my window up to get way further down, maybe go to -50 on the y-min to see the graph that was down there that I didn't see. When I do that, I start losing perspective on that part of the graph. And now if I draw the line y equals x, turning this on, you'll see how the graph gets drawn to that. In a distorted window, it's maybe not the best picture, but nevertheless, you can see to the right and to the left, the graph is going to get drawn to that. If I go further left by changing my x-min, maybe like to -50, you'll start to see better the left hand of the graph, but not so much the right hand of the graph. But you'll see better the impact of that slant asymptote. And so the slant asymptote is a diagonal line that the graph gets attracted to. You get it when the power of x in the numerator that's biggest is 1 bigger than the highest power of x in the denominator. Hey, that's the whole thing. So the next section is going to be essentially just a duplicate of this section. I could have done the 2 sections in one, but it's going to have me do all the steps that we just did, find domains, vertical asymptotes, x and y intercepts, horizontal or slant asymptotes, and then it's going to ask me to physically sketch a graph. And the physically sketching a graph part, I'm going to use my calculator for the most part. I'm going to draw in the features that I'm asked to find by hand, and then the graphing part I'm going to use for my calculator. Again, this is beautiful, beautiful preparation for any calculus course, because in calculus you graph a ton of fractions, and to get the finer details of the graph you need calculus, but the vertical asymptotes, horizontal asymptotes, X-intercepts, Y-intercepts, domain, all of those things you can do without calculus. So if you get that part of graphing perfected now, when you get into calculus, if you get into calculus, then adding the calculus to it won't be a big step. You'll be right where you need to be, rather than having to learn all this and then learn the calculus at the same time. So this is really going to be important for even if you take brief or regular calculus, you graph a ton of fractions.